All right, everyone. Thank you very much. Thank you for that public service announcement. Next, I would like to welcome Frankie Bonte, Kilo Echo 8, Hotel Papa Alpha, and Seamus Bonte, Kilo Echo 8, Golf Tango Tango from DeSales High School in Columbus, Ohio. And they are going to talk about hams, the first makers.
Okay. Hello, everybody. The title of our presentation is Hams, the First Makers, with an introduction to makerspaces. So, first, we wanted to talk a little bit about ourselves so that you could get a better idea of like how we came to makerspaces. So my name is Frankie Bonte. I'm 16. I'm a junior at St. Francis de Sales High School. I love learning math and science, and I also study classical ballet, and I'm involved with choir and drama. I'm a technician. My call sign is KE8HPA.
My name is Seamus Bonte. I am 14 years old. I'm an 8th grader at St. Paul School in Westerville, Ohio, which is just right outside of Columbus, Ohio. I play the bagpipes. I also, so yeah. Yeah, exactly. I also play lots of sports like football, basketball, wrestling, lacrosse. I'm a general, and how I got into ham radio was mainly gaming and computing and computers, and as well as my dad just pushing me into the hobby.
So you saw the title of our presentation, Hams, the First Makers. We first wanted to start off by defining what we mean as a maker, and we found this definition saying the maker movement is a contemporary culture representing technology-based extension of DIY culture that intersects with hacker culture and revels in the creation of new devices as well as tinkering with existing ones and generally supports open source hardware. So basically, makers can be inventors or tinkers who work with something, change existing things to fit their needs. And although this is the contemporary definition of a maker, hams have always been makers. So parts of this was previously touched on in the keynote speech last night and some other talks this morning. But dating back to the late 1800s, people began experimenting with wireless telegraphy. And there began getting a lot of more magazine articles and different things talking about simple experiments. So there was a 1901 issue of Amateur Work that showed how to build a simple system based on Hertz's early experiments. And so this started encouraging people to become makers. There were also stories like this 1904 story of a transmitter and receiver system that had a range of 8 miles. And, and a 1906 story of some Rhode Island teenagers building a radio station inside of a chicken coop. So we included a picture of our chickens. So this showed people how to use the materials available to them to fit their needs. Also, we have a screen capture of the 1939 MGM film called Radio Hams. It's on YouTube if you want to look it up later. But there is, in the picture is Johnny, and Johnny's sitting at his radio. And then in the next scene, it pans to his ma, who's in the kitchen, and she's trying to bake a cake. She's looking for some of her stuff. Turns out Johnny stole her cake tin, funnel, and sieve to build his radio. So moving on into the 1950s and 1960s, every station required a certain level of expertise, but there was also a certain level of experimentation that was required. As radios became more complex with the use of AM and CW, one would scour the neighborhood for parts in old electronics or find materials in the military surplus that was available for an overall lower cost. And because of these low costs, that also aided in the boost of experimentation, because if it was lower cost, then everybody could do it. There was even a Boy Scout badge for building a crystal radio. So this was contributes to the maker mentality. Homebrew continued as parts were readily available. In the picture, we have a Heathkit lunchbox radio, and it's a tour. So this was also during like peak sunspot cycle, so it aided in a lot of worldwide communication, and so it was easier to be successful, so more people were willing to get involved and take the chance. Hams also pioneered VHF technologies that formed foundation for TV, FM, and cell phones today. Into the 1970s and 80s, there was increase in new modes of communication, including SSB and FM, and mobile radios became widely used by people, and beginnings of satellite operation, including space communication both ways. So this is continuing along with people making. Next, into the 1990s and 2000s, we have more digital modes, including packet radio, bulletin boards, and the development of first computers attached to transceivers to create more digital modes that we use today. And 2010 and beyond, we have other digital modes, including Whisper, and some of the other ones that are listed up there. And new technology, including solar power and battery technology that'll increase our efficient energy use. In the picture, we have a balloon launch and a CubeSat in the bottom. So every ham is part machinist, electronics technician, computer scientist, all wrapped into the magic and mystery of ham radio.
So now, I will be talking a little bit about Makerspace. A Makerspace is a new creative stomping ground for all entrepreneurs, creative machinists, ham radio operators, and anyone who just wants to get involved in a new community. And in fact, here at Case Western, we have one of the very best examples in the whole country of a Makerspace is the ThinkBox. Makerspaces provide access to specialized equipment and resources for opportunity and group activity. Makerspaces, like ThinkBox here at Case Western, there's also one at Otterbein University, it's called The Point, are the great examples of Makerspaces. So each Makerspace is kind of broken down into little shops or groups to make it easier for the worker to get around. There are word shops, metal shops, electronic shops, graphics labs, textile spaces, computer labs, and robotic labs. So I think everybody knows what a 3D printer is by now. Every time we go to Micro Center, which is a computer store, my dad veers off to the right where the Arduinos and Raspberry Pis are. And now it is a fun space to be in, but sometimes I can get a little bored with watching him walk up and down the aisles, looking at all the discount prices. So I just go over to the 3D printers and look at what they're making.
So over here we have some examples of some of the things that can be made and that hams can use by the 3D printer. We made these little call sign paperweights that we all have on our desk by the radios. So all of our call signs. We made these little boxes that are SD card holders. So you can have all of your SD cards that aren't being in use in the same place. We have other things like cases. This is just like a charger case. And here's another case for, yeah.
So a 3D printer, again, it's just melted plastic. It's almost like a hot glue gun, and it prints whatever you want. It's all left up to the creative mind. So next is a laser cutter. A laser cutter uses a high-power laser to engrave or cut plastics, wood, and other materials using light and heat. Hams can use a laser cutter by cutting panels, etching labels, preparing printed circuit boards, and cut boxes from plywood or clear plastic. And right here we have a little chip of just a little design that we made using a laser cutter.
All the pictures that we have are taken at
Yes.
Otterbein's Makerspace The Point as well.
The next thing is a CNC machine. CNC stands for Computer Numerical Control. A CNC manufactures parts by cutting or subtracting. Now, so the 3D printer adds to, making whatever you want. Now, the CNC machine and the laser cutter are subtractives. They take away from the material that you're trying to create. Hams can use this for making anything from printed circuit boards to antenna parts. So here's the real biggie. Here's what I think everybody likes in here. The electronic workbench. It's a mix of electronic tools, so soldering equipment, multimeters, bench supply, So signal generators and digital oscilloscopes. So the question is not really how can a ham use a workbench, it's how can't he use the workbench? Is there anyone here who can't use any of this equipment? So here's a relatively new machine that I just kind of learned about, a vacuum form machine. And it uses heat and vacuum to create molds and packaging from plastics. One way a ham can really use this tool is weatherproofing all their outdoor gear and Arduino-controlled coax switch. So my big makerspace project was my science fair project this year. It was the effective antenna type on range. So I constructed antennas, swept at bench, tested for signal distance, and reported on all the results. So I constructed the antennas from aluminum, copper wire, RG401, and SMA connectors. I did lots of soldering for a couple of weeks. And then I had the opportunity to test the antennas at the point with tracking generator and spectrum analyzer. And I did this with an RF engineer from Nicola Labs. I built 3 different types of antennas. I built a Yagi, a panel, and a dipole. And then I conducted my experiments inside of one of the university buildings. And as you can see here, here's me soldering, here's me with the engineer, and here's me actually conducting my experiment. And then what I did was I pretty much printed everything out that I needed, all the documents, and posted it on my, my science fair board.
So what? Basically, why are we talking about hams makers and the maker spaces? As mentioned in last night's keynote speech as part of the Ham Radio 2.0, all of this stuff is very important for the future of ham radio. Today's makers have many of the same traits as a ham. They love to create technology and put it to use to benefit others. But there's a growing problem facing hams that continue want to be makers. Makers require key resources, knowledge of the subject matter, and materials to continue making. And just as radio clubs bring together hams to solve problems and make solutions, makerspaces provide a geographic location where people can meet to work on problems together.
So the average age of hams are rising, and many are downsizing their ham shacks or just houses in general, and they don't really have the space to keep their machines and tools. And so this is what a makerspace can do. It's relatively inexpensive, and it's low cost to the user, and everyone needs an Elmer. You could just go there, get some coaching, learn from a new community, and have a lot of fun.
But one of the most important things to ham radio is the community.
I don't think anybody wouldn't be here without the community of ham radio.
So basically, what we're trying to say is that hams will benefit from makerspaces.
And makerspaces will thrive from hams.
Does anybody have any questions?
Are there any competitions that are common with makerspaces? I'm kind of sort of a member of a couple, but I haven't really experienced them having any kind of a competitive activity or an award type achievement activity based on using the equipment or adapting the equipment.
Yeah.
And I think hams could really hybridize really neatly, and I've just seen a couple of projects. There was one in QST this month where they're going to make weatherproof coax pigtail housing. But is this not working? Oh, okay. Well, we can't have that. Okay. So anyway, what I'm really interested in is some kind of a hybrid activity that would sort of be competitive, that would involve hams and the maker community doing something together.
Yeah, that would be.
I like to compete. I consider myself a very competitive person.
Well, that explains the bagpipes.
Yeah, exactly. My school actually has a small maker space. It's called the Idea Lab, and we have a 3D printer, I think a small laser cutter, and like some sewing machines. And I know we do like little Lego builds and rockets, and I'm sure anywhere you're going to find someone who wants to start competitions at any maker space that you go to. So yeah, there's definitely some competitive stuff there. Any more questions?
So as young people who are getting involved in the makerspace, to us old guys out here that have maybe have a lot to contribute here, what do you see as the best way we could get involved? Because I see lots of hams, and they don't know where to get started. What they want to help? What's valuable? Is it contributions to the local makerspace? Is it Elmering? Is it what do you see as the most valuable thing to you?
Well, I think that a lot of people come to Makerspace not really knowing how to use some of the machines and stuff like that. And at the Makerspaces that we've been to, it's been very beneficial that there's been somebody there that knows how to teach us and not only like help us in that particular instance, but also teaching us how to use the material in the future if we were to like come back again, and then that will continue the spread of knowledge. Seamus, do you have
the teachers, they teach you, but they also want to learn. And I think anybody wants to learn anywhere they're going, and they're just starting off as like a newbie. You want to learn, and that's what makerspaces can do. They can teach you. Any more questions?
Case appreciates the shout out for ThinkBox. Have you seen it yet?
We have.
No.
All right, I remind everyone, this afternoon we'll have tours of ThinkBox. It's really an extraordinary makerspace.
Yeah.
And I will take the liberty of speaking for the admissions office of Case Western Reserve University.
Yeah.
And remind you that the university has a fine amateur radio club.
Yeah. We've definitely seen lots of pictures of it, and it is like 4 stories, right?
7.
7 stories,
yeah,
yes.
I took a tour of campus yesterday,
that's right.
and I got to see a couple of the labs, but they didn't actually take us inside of the ThinkBox.
Yeah, exactly.
Yeah.
Yeah. But any more questions? Oh, thank you very much.
Thank you so much.